Hello boys and girls, welcome to the Math Club. In this video, we're going to talk about Mathematics Year 9 Achievement Test, October 2022. Question 8. The ratio of adults to children at a hotel is 5:3. There are 120 children at the hotel. How many adults are there at the hotel? Now, as you can see here, they gave us the number of children and they gave us the ratio of adults to children, and they need the number of adults. So children, adults, and we have the ratio, so let's do it together here. So first we write A for adults and C for children, and then we write the ratios. The ratio of adult is in order, adults to children 5:3, so 5 here, and then ratio 3. Okay. Now, the number that they gave us, 120, is for children. So we write 120 under children. But adults here we don't know, so we leave it empty. So we write 120 here. Okay. Let me do it like this. Now, you can use this method. We call it the X method. You can use it like this. You put boxes here, like this. Now, I know that children are 3 in the ratio and 120 in real life, or the number of them. Now, to find the number which is here of adults, I just cross multiply. So I cross multiply these by each other, multiply this by the 5, and then divide it on the 3 so I can get the number of adults. Or I take the 120 here, divide it by 3, and then multiply it by 5. It's up to you, whatever method you like. Most students like to use the X method. It helps a lot with answering a lot of these questions. So first, we multiply 120 by 5, 120 times 5, and then divide it by 3, divide 3. And the answer will be the last one, which is 200. And this is the correct answer for this question. So focus when you use the ratio. You have to focus on what number you have here. This is a part number. It's not the whole number, it's a part number. Some questions will give you the whole number, which is the total number of adults and children. But this one is a part number, it's not the total number. That's why you use this method. But if it's a total number, you're going to use another method. I'm going to explain it when a question like that comes to us, okay? Now, that's the right answer for this question. Focus on the steps and how we found it. Now, let's move on to the next question. Question 9. What is the value of this? Now, you can use a calculator to find this. It's not a problem. And it will give you the final answer. But if this question comes in section B, you need to write the steps on how to find this answer. Now, the steps of finding the answer of this question is to deal with each one of them alone. First, you turn this into improper fraction. Same idea, you turn it into improper fraction. And we talked about turning into mixed numbers into improper fractions by using this method. You put multiply here, and then you put addition here, or plus. You do the same for this one. Now, first you write the same denominator. You have to write the same denominator. Let's do it here. So it's going to be 3 down as a denominator. And then we multiply 3 times 1 equals 3. 3 plus 2 equals 5. Very good. So it's going to be 5 in the numerator here. Make it as a fraction. We put the multiplying sign like this. Same idea, we're going to do it with this one. Or let's do each one on each side, this one on this side. Now for this one, I'm going to do the same. I'm going to put the multiplying sign and the plus sign. Okay. Now I'm going to use the same denominator, same idea, which is the 4. I'll put it here. And for the numerator, I'm going to find 4 times 2 equals, very good, 8. 8 plus 3 equals 11. Good job. So this is 11. Now I'm going to take both of the improper fractions and multiply them as the question says. Now, when you multiply the numerators alone and the denominators alone. So I'm going to use this space here for multiplying. So 11 times 5 equals, very good, 55. And then 4 times 3 equals, good job, 12. So this one is 55 over 12. 55 over 12. I'm doing the steps because some questions will come to you in section B, and they will ask you for the steps. That's why I'm explaining in steps. You can do the whole thing with a calculator and it's not a problem for you. Now 55 divide 12. 55 divide 12. Now how do you turn an improper fraction into a mixed number? We're going to do the opposite of this method. Now we're going to turn it into a mixed number. A mixed number is a number like this, which has a number or a whole number, a numerator and a denominator. Now, first step we do, we put the same denominator. We're going to take the denominator, put it the same. So it's going to be 12. We use all the opportunities to explain a lot of topics. So that's why I'm explaining how to turn from a mixed number into an improper fraction. And here we're doing the opposite, improper to mixed number. Now first we use the same denominator. Now what do? Very good. We divide 55 over 12. We divide 55 over 12 using a calculator. So 55 divide 12. As a decimal number, it's going to give me 4.5. I'm going to take the 4 only, put it here. After taking the 4, I'm going to use this method, the multiplying thing. So I'm going to multiply 4 by 12 and check what it will give me. 4 times 12 equals 48. So I'm going to take the 48, write it here, and minus it from 55. So it's going to be 55 minus 48. And the answer, I'm going to put it here. So again, we put the same denominator, divide 55 on 12, we get 4.5. We use the 4 only. Multiply the 4 by 12, we get 48. We subtract it from 55, we will get the numerator's number. So 55 minus 48 is going to be 7. It's going to be 7. So the final answer will be 4 and 7 over 12. So this is the final answer for this question, 4 and 7 over 12. And this is how you answer a question like this. Focus on the steps of turning mixed numbers into improper fractions and the opposite technique. Okay. Now let's move on to the next question. Question 10. What is the value of all of this? Okay. Now to find the value of this, you can use a calculator and find it without any problems. You do the same steps, you put the same numbers, and then it will calculate it for you. If it's in section B, you have to write the steps. Writing the steps, it means finding each one alone and then finding the final answer in the last step. I'm going to do it with steps so you understand each idea alone. Now, 4 power of 3, I'm going to do it in the calculator. It's going to be 4 power of 3. It's going to be 64 here. And I'm going to write it on top here, 64. Okay. This is multiplying. 25 multiply 41. So I'm going to do it first. 25 times 41. Because multiplying is stronger, or yes, stronger than addition and subtraction. So I'm going to do the multiplying first. So it's going to be 1025. And this is a plus sign, so it's going to be plus 1025, like this. Okay. And then we have minus, we write minus. This is the square root of 64. Square root of 64. I'm going to put it in the calculator. And the square root of 64 is 8. So I'm going to write 8. And then divide 4. Okay. Now, I'm going to do the division first. Same idea. Division first. So 8 divide 4 is going to be 2. Very good. It's going to be 2. Now, to do the division first, here, I'm going to write the whole question again here. 64 plus 1025, and then 8 divided 4 equals 2, so it's minus 2. And then I find all of this in the calculator, which is 64 plus 1025, and then minus 2. And the answer will be, very good, the last one, which is 1087. As I said, the steps are done because I want you to understand each and every single step of these. Now, if the question is in section A, you can put the whole thing in the calculator. It will give you the right answer. And this is the correct answer for question 10. Now, let's move on to the next question. Focus on all the steps and how to do it, okay? And focus on how to use the calculator to find these answers. Now, question 11. We have a scatter graph here. Let's take a look at it. Use the scatter graph to predict the temperature of a drink that has been made for 20 minutes. We're going to predict a temperature for this drink, okay? First, let's see. We need to make it bigger. Yes, let's make it bigger, okay? Now, this is the scatter graph. This is the temperature. The drink is made for 20 minutes. Now, when we look at the minutes here, we have more than 20 minutes. They need the 20 minutes temperature. So to predict a drink for 20 minutes, it means we have to follow the 20 minutes. But before that, when we see a scatter graph, we have first points here, put for you. We have to use the best fit line, or the line of best fit. What does it mean? It means it's a line that goes through all the line dots, and we don't care about extreme data. It only goes through most of the dots, okay? Now, let's take a look here. To put the line of best fit, we're gonna go like this, like this, like this, like this, yes. We almost touch most of the data like this. Yes. Yes, I can move it like this a little bit. Yeah, like this. Most of the data is on the line. Now, to find the temperature of this drink, which is what? Which is in 20 degrees, I come to the 20 degrees, which is here. I'm sorry, after 20 minutes. We find the temperature after 20 minutes. So we come to the 20 minutes. We follow up until the line stops me. So it's here. Now I come from here and I go to the temperature, which is over here. So the temperature of the drink, which is made for 20 minutes, is 40 degrees or 40 Celsius. And this is how you answer a question like this. First, you have to put the line of best fit. Don't care about the other points. We call these points extreme data or outliers, okay? And then you follow the 20 minutes line until the best fit line stops you, and then you go back to the temperature to check your answer. So the answer for this question is 40 degrees Celsius, which is this answer here, okay? And this is how you answer a question like this. Now, let's move on to the next question. That's 11. Let's move on to 12. Yes. Question 12. In question 12, let's see. First, let's cover this so we can use the space to work it out. Yes. A box contains 4 counters. One is blue, one is green, one is red, and one is yellow. Another box contains 3 counters. One is blue, one is green, and one is red. A student takes 1 counter from each box at random. What is the probability that the student takes 2 red counters? So we're talking about the probability of taking 2 red counters. Now, let's first make a little bit of a drawing here so we understand the question. We have 2 boxes, this box and this box. Okay. The first box contains 1 blue. Let's write them in letters. 1 blue, like this. one green, one green, one red, and one yellow. One red and one yellow. So we have 4 counters. The second one has 3, which is one blue. Let's make it blue. One green and one red. One green and one red. So we have 2 boxes. The first one has 4 counters, second one has 3 counters. Now the question is, a student takes 1 counter from each box at random. What is the probability that the student takes 2 red counters? 2 red counters. Now for this question, first we find the probability of taking a red counter for this box here. How many red counters do we have here? It's 1. So the probability of taking 1 is 1 over, very good, 4, because all of them are 4. So the probability of taking a red counter is 1 over 4. Very good. Now, let's take a look at the second box. What's the probability of taking a red counter here? Same idea, the red is 1, and all of the counters are 3, so 1 over 3. 1 over 3. So we know the probability of taking a red counter from this box and a red counter from this box. Now, these events are what? They are dependent. Why are they dependent? Because they depend on each other. Because a student taking 2 counters or 2 red counters, it means the first one must be red. The first one must be red. So what do we do to red, or what do we do to dependent events? We multiply the probabilities of these events together. We multiply the probabilities of these events together. You can answer this using this method or the tree diagram. Now, I'll show you the tree diagram after finishing this method. First, we take these 2 probabilities, 1 over 4 and 1 over 3, and we multiply them by each other. So 1 over 4 times 1 over 3, the answer will be 1 over 12. 1 over 12. And this is the correct answer for this question. Again, you can answer it using this method or using the tree diagram. Now let me explain this question using the tree diagram. In the tree diagram, let me cover this first here, and I'll show you how to do it. The answer is 1 over 12, as I told you. We will check, okay? In the tree diagram, we already know the question, which is these 2 boxes. So we first make a tree diagram like this. This is the first box. And then the second box. Okay. Now, we write first box and second box, okay? So you understand the idea. Now, let's put them down so you understand more. Here, here. I'm just going to explain by using red and not red. We don't have to explain using all the colors. We only focus on the red. Now, let's say first box, you pick a red one. Let's make it red. And here, second box, red one. And here, not red. So NR. Okay, let's call it NR. Same idea, NR, not red. So this idea means what? It means the probability of picking a red one from the first box is what? This is the first box, by the way. And this is the second box. The probability of picking a red counter from the first box is 1 over 4. So we write 1 over 4 here. Okay, let's make it smaller. So the probability of picking a red box or a red counter is 1 over 4. And not picking a red counter is going to be 3 over 4. We don't need this. And then the second box, the probability of picking a red one, same idea, it's going to be 1 over 3. 1 over 3. Here. Okay. So we know the probability of picking a red one from the first box and a red one from the second box. Now, picking a red one from the second box depends on picking a red one from the first box. That's why we call these events dependent events, because they depend on each other. And because they are dependent events, we have to multiply the probabilities of their events. So we multiply 1 over 4 by 1 over 3, and the answer will be 1 over 12. And this is how you answer a question like this. I hope you understood the idea. You can use the tree diagram like this, or you can use the boxes method. It's up to you, whatever method you like. Now let's move on to the next question. Question 13. Let's zoom in so we can see it better. Yeah. In question 13, we have to factorize. Factorizing these, let me go with this, okay. Factorizing or finding the factors of these questions depends on steps that we have to understand. I put a video to explain this more, but I will explain it again here, okay? Now, here we have x squared minus 7x plus 7. First step we do is what? Let's zoom in so I can show you the idea of factorizing. And then, after knowing the answer, we will choose it. There. Okay, so we have x squared minus 7x plus 7. First, we come here to the last sign, we put plus, it means add. Plus means what? Means add. Follow these steps and you'll be good in factorizing. So plus means add. Now, first step we do, we open brackets like this. After opening brackets, we come here. X squared means x times x. So we put x and x. Follow the steps. So plus means add. X squared means x times x. Now we need to know the signs inside the brackets. How do we know the signs? We look at this. This means what? It means add. When do you add? If you have the same signs or different signs? Very good. If you have the same signs, it means you add. So it means here we have the same signs. We must have the same signs. Now, having the same signs means what? Means, yes, very good. Means they are the same here. So how do we know the sign? We look here. Very good. We look here. Here means having the same signs. It means we look here to know what's the sign. So because this is negative, it means we put negative here and negative here. So as I said, focus on the steps, you understand how to answer the question. First, we look at the sign. It's addition. It means we must have the same signs, and the signs must be negative. Addition, it means look here and put the sign. Okay? Subtraction means different signs. It's easy, okay? Now, we need two numbers. When you multiply them, you get 6. When you add them, you get 7 or minus 7. When you multiply them, you get 6. When you add them, you get minus 7. Now, how do we find this? We take the 6. We have to factorize it. We put it here. We factorize it. So we put 6. Okay. We find the factors. It's 1 times 6. 2 times 3. And then 3 is repeated. We're not going to use it. What else in the 6 factors? Nothing else. That's it. So we need two numbers out of these. And they must be together like this. 2 or 3, 2 and 3, 1 and 6. Two numbers. When you multiply them, you get 6. Good. Both of them, when you multiply them, you get 6. When you add them, you get 7. Is it 2 and 3 or 1 and 6? Very good. It's 1 and 6. So we take the 1 and the 6, we put them here. We put 6 and 1. If they have the same signs, it doesn't matter the order, 1, 6, 6, 1. But if they have different signs, it matters depending on the answer of the addition. Or subtraction, I'm sorry. Because different signs means subtraction. So the answer will be x minus 6 and x minus 1. And this is how you find or factorize these quadratic equations. Now, let's check x minus 6, x minus 1. Let's check the answer, which is A. Very good. X minus 6, x minus 1. Now, you can watch the video again, and you can watch the other video that explains the right steps of finding or factorizing quadratic equations. Now, let's move on to the next question. You have to focus on the steps. Question 14, find the solution to the equation. Find the solution to the equation. Now, let me first cover this so we can use the space. X squared minus 34 equals 290. X squared minus 34 equals 290. Now, to find a solution for this equation, first let's write it here. So x squared, or x power 2, minus 34 equals 290. Okay, equals 290. Now, first step we do, we take the minus 24 to the other side. We need the x alone, so we're going to take the minus 34 to the other side. It's going to be plus 34. Good, we change the sign. So we're going to have x squared here equals, focus on steps of algebraic equations, 290 plus 34, okay? Now, 290 plus 34, 290 plus 34 equals 324. 324. So x squared equals 324. Equals 324. Now, to remove the square, we have to do the opposite of a square, which is, very good, a square root. A square root. So I'm going to square root the x squared. Let's put it here. X squared equals 324. Now I'm going to square root both sides. So I'm going to square root this one. And I'm going to square root this one. The square root of x squared equals, very good, x. And then equal sign. Now the square root of 324, square root of 324 equals 18. Equals 18. So the correct answer, or the value of x, is, very good, 18. And this is how you answer a question like this. Now, let's go back again. First thing we did, we took the 34 to the other side by addition and changing the sign. We add them, we get 324. And then to remove the square, we do the opposite of the square, which is the square root. And then we get x equals 18. And this is how you answer a question like this. Now, let's move on to the next question. Question 15. Which integers satisfy the inequality shown on the number line? Now, this is a number line. This is the inequality. These are the parts of the inequality. You have to find the numbers that satisfy this inequality. Now, first you have to understand the meaning of these dots. And what does it mean if it's closed? And what does it mean if it's open? Now, an inequality means what? An inequality means it uses the unequal sign, which is bigger than or smaller than, and it adds the equal sign sometimes to the bigger than and smaller than. So we use these signs, for example, this sign and this sign. Okay? Now, if we use these signs without the equal sign, which is underneath it, it means the inequality will be an open circle like this. So it means the number here is not included. It means the number is not included. So if the circle is open, it means it's like this, bigger than or smaller than. But if the circle is closed, it means there's an equal sign under the bigger than and smaller than. So if you see an equal sign, it means the circle will be closed. And closed means the number here is included in the inequality integers. It means what? It means we include the 2 and we don't include the 7. So the answer will be what? Very good. Let's count. Here we have 2, 3, 4, 5, and 6. So the answer is 2, 3, 4, 5, and 6. We don't include the 7 because the circle of the 7 is open, and we include the 2 because the circle is closed, and this is how you answer a question like this. Thank you very much for watching. See you next time.